Okay, so we're going to talk about the most basic type of interest today. And that is simple interest. We talked about it a little bit when we compared it to compound interest a couple class times ago. Simple interest is for what we call lump sum investments only. You're going to hear that term a lot, but lump sum just means one-time investments. And then we'll talk about kind of what simple interest loans look like also. Okay. All right, but the reason it is called simple interest is because it's actually just interest on the principal only. Whereas compound interest, you're actually paying interest on the interest itself, which is why it has that snowball effect that we looked at a couple class times ago. Okay, it's a constant dollar increase, okay, based on whatever the interest rate is. And we already talked about this, but just make sure that you know that the term principal is the original amount. So one of these formulas we've already talked about, but I want you to include it here anyway. So here are the formulas for simple interest, and it just kind of depends on what you're looking to find. The first one is I equals P times R times T. Okay, I is the interest earned. So if you were just kind of concerned with how much extra interest there was, you might use this formula. We already talked about it, but P is the principal. We talked about this last time we talked about finance, but what is R? R is rate. Okay, it's always written as a decimal, like always. So if it is 4%, make sure you know that that's 0.04. T is going to be time in years. With finance, it's always years. Okay, so if it happens to be months or something like that, you would have to transfer that into years. And then here is the formula if we want to find the final amount, because remember A is the accumulated amount. That's what the A stands for. So it's the accumulated amount after the time t, but a lot of people just call this the final amount. So there are some loans out there that work with simple interest. Okay, again, kind of like we talked about before, you don't get to pick what kind of interest your loan has. You just need to be aware of the fine print to know what kind of loan you've got. I think my car loan is simple interest, but lots of car loans aren't necessarily simple interest. So it just kind of depends. All right, so let's do a couple examples. So if you have a calculator, go ahead and get that out. You will want to bring your calculator over the next couple weeks to class because we're going to be doing some problems that will be more helpful if you can punch them in as we go with me into the calculator instead of just watching me do it. All right, so we're going to find the interest earned over 4 years on $500 invested at 8% simple interest. Okay. The first thing is that I want you to notice is when the conditions are simple interest, it's going to state that. Okay. If it mentions anything about compounding, that is compound interest, not simple interest. Okay. And then also it's asking you to find the interest earned. Okay, so which formula would give me the interest earned of the two that I have written up there? The I one, yeah. So we're going to use I equals P times R times T. Okay, and let's just plug in what we know, right? We know the beginning principal was 500. We know the rate is what? 8, right? So how do we write that as a decimal? 0.08. And then the time is 4 years. Okay, so a pretty consistent formula, pretty easy to punch in, but we would just do, let's see if I can get it out of the glare here. We would do 500 times 0.08 times 4, okay, and so we would get 160. So this is basically $160 in 4 years. So we're going to write down that, because I want you to understand that actually that means it was a constant how much a year then. If you divide 160 by 4, how much a year would that be? 40. Okay, so simple interest is kind of like the name implies. It's very, very simple. It's constant. Compound interest is different every year. We looked at that when we looked at kind of the snowball effect in that little chart we looked at. All right, so let's look at maybe another one. So find out how much money you would have after investing $800 at 6% simple interest for 1 year and 9 months. So the first thing is I mentioned that it's simple interest, which tells you we need to use our simple interest formulas. The reason I'm making a point with that is this section is all simple interest, but pretty soon we're going to lump a whole bunch of financial situations together, and you're going to have to make sure you're reading properly to know which formulas to use. So notice that I asked how much money you would have. Okay, so in other words, I'm not just asking you for the interest, I'm asking you actually for the what? Yeah, the final accumulated amount. So you want to use A equals P times 1 plus RT. Okay, you must have the parentheses there. It's important or it won't give you the right result. So we invested $800, right? The interest rate's easy enough, right? What would the interest rate be in decimal form? 0.06. Okay, by the way, one of the most common mistakes is for people to only move the decimal place once and say 0.6. But you will get an unreasonable answer, because what kind of interest is that? 60%, which is super, super high, right? Nobody's getting 60%. But then we need to figure out what time is, right? So how do we figure out 1 year and 9 months? Maybe off to the side. Okay, we basically have 1 and 9 out of 12 months. Okay, so what does 9/12 reduce to? 3/4, okay? And so you can either say 1 3/4, or you can say 1.75, okay? Because we're going to be using it in a calculation, it's probably easier for me to list it as a decimal. However, if it's like a third or something, a third, remember, is 0.3333 forever. You'll have to use a fraction to get the correct answer. So make sure that you're accurate, but the only reason I like decimal form here is just because it's still just as accurate as 1 3/4. So you end up getting $884. Okay, so let's talk about some of the common mistakes on the calculator. Okay, so let's punch it in, but it's 800 times parentheses 1 plus 0.06 times 1.75 close parentheses. So I'm going to move it over here, maybe. If I can get it out of the glare. There we go. All right, so notice that gives me the correct answer. So here's some common mistakes. Okay, some common mistakes are to forget the parentheses. Something like this. Okay, notice that if you forget the parentheses, I don't think that's a reasonable answer. How much interest are you only earning? Like between 10 and 11 cents, right? So that's too low, right? So remember I said another common mistake is to do 60% instead of 6%. But I just want to show you just what kind of ridiculous answer it gives you. $1,640. That's more than, well, that's right around doubling it, right? Not more than, but right around doubling the money in a year and 9 months. Okay, so that's too much, right? So make sure your answer seems to make sense. It should be more than 800, but it shouldn't be a crazy amount more. But it also should be more than, 11 cents more. Okay. So just kind of while we're on the topic, make sure that you're using accurate numbers. So remember when I said if it were 1/3, you would want to use 1/3 instead of 0.3. Do you think people care if you're off on their money? Yes, right? People really care if you're off on their money. Okay, you have to make sure that you're accurate when you're speaking about people's money. Okay, so I want it rounded to the nearest penny. Okay, in this case, we weren't talking about pennies, but if it applies, you need to round it to the nearest penny, and it needs to be accurate. Yes.
So this is probably a dumb question.
No.
But if you got 6% of 800 and multiplied it by the time, like, would you still get the same answer? I'm just thinking of like,
if you found, if you did that, you'd be using the interest formula, and then you could just add it back to the original amount.
Yeah,
and that is the exact same. Yes.
What I would do in like real life if I
right.
did that.
Yeah.
But the
So.
formula is probably
Well, because I mean, notice if you distributive property this would be P plus P times R times T, which is the interest formula. So yeah, that would totally work. Okay, so that would be just fine. Okay. So just remember, we're looking for accuracy here. It's more important than you might think when you're discussing people's finances. All right, so let's move around what the unknown quantity is. So what if I asked you to find how much was originally invested if after 13 weeks and 16% simple interest, let's say after that time period the account has $910. Okay, so notice my key phrases I need to pay attention to are the fact that they use the term simple interest. Okay, but this time they're asking how much was originally invested. In other words, what are you trying to find this time? We're trying to find P. Okay, we're going to still use the same formula, but our unknown quantity is going to be different. And we're just going to maybe have to use a little bit of algebra to get the quantity that we actually want. All right, so let's plug in what we know. Okay, we know the final amount in the account was 910, right? That's not the principal. That's not what we started with. That's actually what we want to know. We don't know P, so we're going to leave it as a variable. We know the interest rate is 0.16. But when we get to time, what do you notice? Time is a little janky on this one, right? So how do I quantify 13 weeks when I really need it to be in years? Okay, well, you just have to know how many weeks are in a year, right? Yeah, there's 52 weeks in a year. So 13 weeks would be 13 out of 52 of a full year, which does reduce to 1/4. Okay, so I could do 0.25, but I just want to show you what it looks like if you decide to use a fraction in the formula too. Okay, so just as easy for your calculator to figure out, but then we're just going to have to do one more step when we're done. So let's figure out what the parentheses is, right? According to order of operations, I should be doing the parentheses first. So let's figure out what 1 plus 0.16 times 1/4 is. Technically, we really should put a parentheses around the 1/4. It's not super important in this case. It actually won't mess it up, but a lot of times it will. So a good general rule is to always put parentheses around fractions. But this piece comes out to be 1.04. So I'm not actually done solving the problem. This is actually 1.04p now, because I figured out all of that parentheses was equal to 1.04. So now what do I do if I want to solve for P? I just divide by that number I don't really want over there, right? So I just use my calculator to divide, and I will get P equals 875. Why shouldn't it shock us that this amount is not that much different than the 910? It's only 13 weeks. It is a very high interest rate, though. Okay, so frankly, the only reason they earned as much money as they did was because it was a 16% interest rate. Okay, but it was only for a quarter of a year, right? So we wouldn't expect it to be that much. So then, what if I asked you for what the interest quantity was? You shouldn't really need a whole new formula. You can just use the information we already have, right? So how would you figure out how much of that was interest? Yeah, so you just do 910 minus 875, and the difference will be the interest that you earned. So it looks like we earned $35. Okay, which is actually pretty good for 13 weeks. But again, that's because the interest rate is actually super high. Okay, so one more, and then we're going to honestly move on to compound interest, because that is more prevalent in the finance world anyway. So you will find simple interest loans, but most of them are compound interest. So how much interest will you pay for a credit card balance? Of $554. That is 1 month overdue. If the interest rate is 20%. And by the way, that's not an unrealistic credit card percentage. Okay, there's actually credit cards out there that are closer to 30%. Okay, particularly the ones they're trying to market to college students. Usually those are 29 point something percent. Okay, very, very commonly. And let's say we're going to ignore any fees. I mean, if you've ever accidentally paid something late, you will have fees, but let's just assume that they're going to be nice and waive those. They're not. Spoiler alert, they're not, but they might. Okay, so notice that we are trying to find what? We're trying to find how much interest, right? So that means we need to use the interest formula. And the reason we can use simple interest is, frankly, only because we're only talking about 1 month period. We're talking about one time frame. If we were talking about building month upon month, we wouldn't be able to use simple interest for this example. Because frankly, credit cards themselves don't use simple interest, but 1 month of interest works the same. Do you remember when we did that table before, how the first element of the table was the same for both sides? That's why one time period doesn't affect anything. All right, so my principal, or what I owed, was $554. The interest rate I'm going to pay is 20%. If it's 1 month, I need to change that into years. So what would 1 month be in fraction form? 1/12. Okay, so if you multiply all of that out, it might not sound like a lot, okay, but $9.23 would be just what your extra interest would be. But again, what would you normally have to pay on top of that probably? You would normally have to pay a fee, okay? Anywhere between $30 and $40 is the typical late payment fee. Okay, and then just imagine if this started snowballing on you, right? That's how people get in trouble. Okay, and frankly, people get in trouble with credit card debt even without paying late, okay, because that interest just continues to snowball forever and ever and ever. Okay, so I didn't want to spend too much time with that type of interest because frankly, it's just not that practical. So we're going to switch over to compound interest. So I don't think we'll finish this lesson today, but we'll catch the rest of it on Friday. So if you're keeping notes by section number, you might switch the page. But I did want to cover these together because I want to show how they're different. Okay, and we already kind of had a preview of this before. So what is compound interest, though? So we looked at this a little bit when we looked at exponential functions. Okay, compound interest is where interest is earned on the principal, just like simple interest. But where it differs is it also earns interest on previous year's interests. Okay, in other words, it is not a constant dollar increase. Okay, so it's not like you're earning, you know, $40 in interest like one of our previous examples with simple interest. All right, so I'm just going to say refer back to the table comparing simple and compound interest. Okay, we did that a couple sections ago in the exponential section. So I don't want you to write this down, okay? I just want to kind of reference it again. So this is a sloppier version of what we did before, okay? And I'm going to move this paper in a minute, and I'll go back to the notes if you didn't quite catch up. So remember, look at the difference between simple and compound, right? What's happening with simple interest?
It's all based on the beginning balance.
Yeah, it's all $10 increments every time, right? But notice here, we're going up by $10 the first year, but then $11 the second year, $12.10 the third year, $13.31 the fourth year, $14.64 in the fifth year. So if you continued this, what would continue to happen to that increase every single year? It would grow and grow and grow and grow, okay? And there comes a point where it can even be larger than what you started with, okay? If money is left long enough and it earns a good enough interest rate, it can actually keep snowballing in that way. And of course, that's the kind of interest you want to snowball, right? When someone's paying you that interest, what kind of interest do you not want to snowball? When you're paying someone else interest, right? So we just want to be good consumers, okay? Hopefully. So if you don't learn anything from these lessons other than how to be a good consumer, then I think I've achieved my goal here. All right, so let's remind ourselves about the compound interest formulas. There are two of them. Anytime you see the word compounding, you're going to be using one of the two of these formulas. So this one, remember, was for periodic compounding. Periodic just means on a time schedule. So this formula looks like this. Bless you. Actually, let's make it M. I think we used the letter M before. The reason for the confusion there with the letter we're using is a lot of textbooks use the letter N as in Nancy, but this textbook uses M, so I have to remind myself to change it. And remember that M is the number of times per year. That interest is compounded. And compounding is just a fancy way of saying the interest is being figured. So this is for any type of periodic compounding, and then remember a couple sections ago we looked at also what we call continuously compounding interest. So that's just what it sounds like. It's just always, it's always kind of climbing. So I call this the PERT formula, but it's not P times E times R times T. The R and the T are in the exponent spot, so make sure you write that properly. So before we look at some examples, I want to get into more than we did last time about how interest is compounded at different frequencies, because this is something as a consumer you do need to know. So interest is always quoted to you as an annual rate, always. Okay, regardless of how often it's being compounded, they're always going to say that this loan is 10% a year or 20% a year or whatever. Okay, so let me show you what I mean by what they'll do with your interest. So compounding monthly So this is just for monthly. Compounding monthly means that your rate is divided by 12. Why is it divided by 12? 12 months in a year. Okay. And then it's calculated monthly. So let's look at an example of what I mean by that. And I'm going to pick an interest rate that is quite high, but also that is going to be easy for us to divide by 12. So let's say that you are offered a credit card that's a 24% annual interest rate. Okay. And let's talk about what it means if we calculate the or compound the interest at different time periods. Okay. So first let's look at annually. What does annually mean? Annually means once a year. So annually means 24% interest is calculated once a year. It's just what you would probably think that it is. Okay. So that's the one that works kind of like you would expect. Okay. But what happens if they change it to, say, quarterly? Okay, how many times a year is quarterly? 4. So what they do is they actually take your 24% interest rate and they divide it by 4. And of course that gives you how much percent? 6, right? So 6% interest is calculated 4 times a year. Okay, so can you see how the general consumer would think that was the same, right? Doesn't that seem like it would be the same? It's 4 times 6, which is 24, right? Why isn't it the same, though? So let me put this back up. This is the reason why it's not the same, right? They're creating more snowball periods. Does that make sense? Okay, they're creating more times where interest is being figured. They're creating 4 times the number of elements on this chart. Okay, and what was happening every time we went to the next time frame on this chart? It was becoming more and more and more, right? So they're not really being dishonest. Okay, they have to state, the federal government makes them tell you how often they compound, but they're not, I would say, being the most upfront they could be. Okay. So if you are compounded monthly with this same interest rate, what does that essentially mean? They're taking the 24% interest they quote you and they're dividing it by 12 because why? There's 12 months in a year, right? And they're charging you 2% interest, which sounds so innocent, right? 2% interest, and they calculate it how many times a year? 12 times a year. Okay. So to be honest, for most people's savings accounts or investments, it really probably only means like a few dollars a year. But can you see how if you can earn a few dollars a year more from 1 million plus people, that means a lot more money for you just by the bank deciding to change the compound frequency. So this is annually versus quarterly versus monthly. So you had a quiz or an in-class activity where I had you figure out how many times typically that credit cards charge you interest. So how many times do they charge you interest typically? Daily, right? So what would they do with this 24%? They would divide it by 365 because there's 365 days in the year. So they would be charging you just a little teeny tiny amount of interest every day But the point is, every day it's growing by a teeny tiny amount, right? And if you increase something 365 times, even if it's just by a penny or two, it matters, right? So that's kind of the point, okay? So we talked about this before, but I really want to drive it home. The more often you compound interest, the more money is earned. So all other things being equal, if you have money that is being calculated or the interest that's being calculated more frequently, it is going to earn more money. I don't know how to spell calculate, I guess. So actually, even more than daily, which type of compounding should actually gain you the most money? Continuously is actually the most money, okay? And frankly, the only reason credit card companies don't charge you continuously is because the federal government doesn't allow them to, okay? That's it. They would charge you continuously if they were allowed to. They're not allowed to, so they're like, okay, well, the next best thing is daily, okay? So that's kind of what they do with that. Okay, so let's look at a couple of problems with compound interest. And like I said, we're not going to be able to finish this today. We'll finish this up on Friday. So find the final amount in an account where $1,000 was invested at 8%, compounded semi-annually for 7 years. So we talked about some different frequencies before when we looked at exponents, so make sure you look those up. So on some of my examples, I do include maybe less common compound frequencies. Semi-annual is a little bit less common, but there are some things like your car insurance pays semi-annually typically. Okay, every 6 months they renew how much you owe for car insurance. All right, so the fact that they mention the word compounded at all means that you are looking at one of the two formulas, either the PERT one or the other one. Okay, I call it the other one because I don't really have a great name for it. But we are compounded semi-annually. Okay, so any time it mentions a time period, it means that it's periodic. Okay, if it says monthly, quarterly, daily, anything like that, weekly, it means that it's the periodic formula. Also note that it's asking for the what? The final amount. Okay, so which formula should we use then? The long periodic one, right? So I think that this book sometimes also uses I for interest instead of R. So just be aware of that, okay? But most textbooks out there use R, so that's what I typically use. All right, so let's plug in what we know, and then we'll use our calculator. So $1,000 is what we originally invested, right? What's the interest rate? 0.08, right? We have to change it to a decimal. And then M is how many times a year semi-annually is, right? Semi-annually means how many times a year? 2. And then we can raise that to the 2 times the number of years power. Okay. So remember, you need parentheses around this if your calculator doesn't look like mine and it doesn't already kind of open up an exponent spot for you. So I know we practiced this before, but I want to practice it some more. Okay, so if you have a calculator, I want you to see if you can get the same answer I've got. But it's 1,000 times parentheses 1 plus 0.08 over 2. By the way, before we finish that, notice what they're doing. They're dividing the interest rate by 2, but they're going to figure it more frequently. Okay, so they're dividing it by 2 because it's twice a year, and then they're raising it to the power of 2 times 7. Okay, so you should get an answer of 1731. Remember, I want to see pennies too, so round it to the nearest penny. Okay, so this is the answer. What if I asked you for the interest? So I don't even think you need a calculator for that. How do you figure out the interest? You just take this and subtract off what? Your $1,000 original investment. So the extra $731.68 was all interest. Okay. So notice, the more frequently noticed 7 years is longer than some of our other examples, right? So we actually were able to earn quite a bit of interest. Compared to our original investment, that's a pretty good quantity of interest. Okay. All right, so let's try another one. This will probably be the last one, and then we'll pick back up with this next class. How much will you have after 5 years if you invest $100,000 at 6 3/4% compounded weekly? So I wanted to do one where the interest rate was not a whole number, because actually most interest rates that you get quoted out there are not whole numbers. Usually they're decimals or fractions or something. Okay, but the fact that it says compounded means we're using one of our compound formulas. Okay, the fact that it says weekly means it's periodic again. And then it's still asking how much will you have. Okay, in other words, what's it still trying to get you to find? A, the final amount. So we're still going to use A equals P times 1 plus R over M to the MT power. But this time, notice we have a much larger starting investment. So how am I going to write 6 1/4% in decimal form? Yeah, 0.675, right? So I always put a 0 before my decimal point just to remind myself that there's a decimal point there. But you can just say 0.0675, but you do need the O after the decimal point. And then it's divided by however many weeks there are in a year, which we already know to be what? 52. And then it's raising it to the 52 times 5 power. Okay. So notice it's dividing the interest by 52, but then it's doing the process a bunch more times, 52 times more than it would have normally done. Okay, so let's see what we get. Okay, and it shouldn't be, you know, crazy bigger. Okay, than the 100,000 because it's only for 5 years. So it would be 100,000. Sorry, I always forget about this glare. 100,000 times parentheses 1 plus 0.0675 divided by 52, and then raised to the power of 52 times 5. Okay, make sure you put parentheses around that exponent if you have an older calculator. But notice you get 140,113.29. Okay, so what about this guy if I asked you for the interest? Yeah, the interest would be the difference, right? So it would be the 40,113.29. Okay. All right, so just make sure, how are you going to tell the difference then on your homework? Like, when is it talking about simple versus compound? It's a pretty easy answer. It's going to say it. Yeah, it'll say simple interest if it wants you to use simple, and it'll say compound interest if it wants you to use compound. Okay.